So in this video we're going to look at the inverting adder. Now the idea is that we take two voltages V1 and V2 and we add them together, and that will be the voltage we get at the output. We could also add multiple resistors in and multiple voltages and add up all of the voltages, and the final voltage is the sum of all the voltage at the output is the sum of all the voltages at the input here. So we have our circuit here with our negative feedback, our resistor RF and the resistors R1 and R2. So let's analyse this using what we've learned previously. We know that from the golden rules that the voltage at V plus is going to equal the voltage at V minus. So we see that V minus is going to equal 0 volts. And then we can use Kirchhoff's current law in order to analyse the circuit. So we can say that V1 minus V minus upon R1 is the current here flowing in this leg, and V2 minus V minus upon R2 is the current flowing in this leg here. Now we know that there's no current flows into the input of the op amp from our golden rule, so all that current must flow in this direction here. So that must be equal to this current here, which is going to be our V minus minus V out upon RF. Okay, now all we've done here is we've taken the final term here across from this side here over to this side here, and it becomes our minus. Okay, and we can then use the fact that V minus equals V plus equals 0, and we can replace all the V minuses with 0, so you're just going to be left with V1 upon R1 plus V2 upon R2, and that minus will cancel out with that minus there, and that's V minus is a 0, and whenever we take it all across here it'll become a minus, so it'll be minus V0 upon RF, and then we can transpose that for V out. So V out is going to equal minus RF times V1 upon R1 plus V2 upon R2. Now you can notice then that if R1 equals R2, we can take that out and you just have minus RF upon our value of R. Okay, now in this instance here I've done the design in Logisim, and sorry, you can see here then eventually that if these are equal, you can take that out and you just have V1 plus V2. Okay, so in Multisim I've built the same circuit up, but I've built it up using 3 inputs, and I've made the inputs just slightly different: 0.5 peak to peak, 0.6 peak to peak, and 0.7 peak value. Going through the resistors, and all the resistors are the same, they're all 1k, and the RF is 1k as well. So it means that in this circuit here all we're going to have is minus RF, which is 1000, divided by this R1 and R2 are the same, minus 1000, so you're just going to have minus V1 plus V2. Okay, so you can see that here, and that's the output I get from Multisim. So you can see that the 3 voltages are here at the input, so the red ones are the 3 voltages at the input, and they've made them slightly different so you can actually see them, and you can see that the output voltage is in white here, and the output voltage, it's been inverted, so a positive voltage here becomes a minus voltage, and a minus voltage becomes a positive voltage, and the peak value there is just the sum of the peak values of these 3 voltages here. So you can see that has actually worked, and it does give us a summation. Okay, so if we were to go in and have a wee look at it in Multisim, so that's a Multisim there, and that's it all built up, and you'll have access to that, so I'll leave a copy of this so you can go and you can build it for yourself and try it out for yourself. So if I was to run that simulation there, it take a second to run because it's a little bit slower. I think it's on hold. So that's it running there. It's actually running slowly because the computer's running slowly at the moment, but you can see it gives your or sum of these three voltages here. Okay, so that's all there is for this video, and the next video we'll go on and we'll look at the another adder circuit. Okay, so thank you for listening and goodbye.